Every photograph represents a fresh revelation, and each one provides humanity with a perspective of the cosmos that we've never witnessed before. There's an incredible amount of detail here. We're observing these galaxies in a way that was previously impossible. The initial batch of James Webb Space Telescope data on 3I Atlas has just arrived, and what it discloses is both captivating and unsettling. Scientists had anticipated this moment ever since the object was first recorded as the third verified interstellar visitor to our solar neighborhood. Expectations were already elevated because both of its predecessors, Oumuamua and 2I/Borisov, had generated waves of excitement, discussion, and controversy. Now, with Webb's unmatched sensitivity and its capability to detect wavelengths inaccessible to prior instruments, the veil has been lifted slightly further. What it uncovers paints a scenario far stranger and more alarming than anyone expected. Before we begin, don't forget to like and subscribe for further updates. From the outset, 3I Atlas stood apart due to its trajectory. Its hyperbolic orbit made it clear that it did not originate within our solar system. That fact alone was not surprising. Astronomers have long theorized that interstellar objects occasionally pass through, expelled from their home star systems and drifting across the galaxy. Yet, 3I Atlas acted differently than predicted by models. Even before Webb trained its golden mirrors on it, Earth-based observations hinted at irregularities in its movement and strange light patterns that defied easy explanation. Some astronomers suspected outgassing, similar to a comet, but the signs were inconsistent. Others proposed unusual surface characteristics, perhaps a crust unlike anything observed on comets or asteroids here. The new Webb data, however, adds layers of complexity that deepen the enigma. The telescope's infrared sensors captured spectra that resisted conventional classification. Instead of displaying the typical signs of water ice, carbon dioxide, or silicate dust that dominate most cometary or asteroid bodies, 3I Atlas exhibited a strange chemical signature. Infrared peaks suggested the presence of complex organic molecules in concentrations far exceeding expectations. Some of these compounds faintly resembled those found on Titan or in interstellar clouds, but their proportions were distorted in a way that implies either a radically different chemical evolution or an origin in an environment not yet studied. Alongside these organic indicators were unusual absorption features that don't match any known substances. Scientists are still debating whether these represent exotic ices, metastable states of matter formed under alien conditions, or something entirely beyond current astrochemical knowledge. One of the most disturbing findings came from Webb's precise tracking of the object's motion. Small deviations from the expected path had already been noticed, but with Webb's precision, it became clear that these were not mere random fluctuations. The accelerations were systematic, directional, and did not correspond to any pattern of solar heating or outgassing known to us. Unlike comets, which emit jets of vapor that can irregularly alter their trajectories, 3I Atlas appears to adjust its course in ways too steady and persistent to dismiss as mere noise. The unsettling suggestion is that either an entirely new form of propulsion is in effect, a natural mechanism previously unobserved, or that the object is not entirely natural in origin. This possibility was whispered about after Oumuamua, which also displayed unusual accelerations. At the time, most scientists strongly resisted speculation about artificiality, preferring naturalistic explanations, however strained. But the Webb data on 3I Atlas makes those explanations increasingly difficult to uphold. The strange reflectivity patterns, chemical oddities, and now consistent motion deviations combine to form a case hard to reconcile with a simple icy rock from afar model. It doesn't prove anything definitively yet, but it urgently raises the question: what exactly is passing through our cosmic neighborhood? Adding to the discomfort is spectral evidence of thermal regulation on the object's surface. Webb detected temperature fluctuations that seemed surprisingly uniform, even after accounting for solar exposure. Natural bodies typically display hot spots and cold areas depending on rotation, surface makeup, and heat conductivity. 3I Atlas, however, exhibited a thermal balance implying something unusual about its material properties. Some have suggested an exotic insulating crust. Others speculate it might indicate engineered temperature control, a suggestion that causes unease even among those proposing it. If a natural explanation exists, it would require discovering new kinds of matter or structures previously unknown. If not, then we may be witnessing evidence of something far more significant. The object's shape further complicates the issue. With Webb's imaging, astronomers resolved more detail than ground-based telescopes could. Instead of a rough, irregular mass, 3I Atlas revealed an elongated and oddly symmetrical shape. While not as extreme as Oumuamua's debated pancake or cigar form, it still did not match the rubble-like shapes common among asteroids or comets. Some described it as unervingly regular, as if its fractures or erosion were governed by rules rarely seen in natural processes. Again, the cautious interpretation is that this is an object formed by physics in an alien star system, subjected to conditions absent here. Yet, the combination of regularity, anomalous movement, and chemical composition feeds a growing sense that something is amiss. Perhaps the most unsettling aspect of the Webb data comes from spectroscopy of the object's trailing material. A faint haze surrounded 3I Atlas, too subtle for earlier telescopes to detect but now visible in high resolution. This haze did not resemble cometary dust and vapor tails. Instead, it consisted of fine particles of an unknown substance with a refractive index unlike anything in current mineral catalogs. These particles did not disperse randomly but seemed to align in faint bands, as if influenced by magnetic fields or some directed mechanism. If natural, this points to interstellar chemical phenomena never before recorded. If not, then we may be witnessing something profoundly different, possibly remnants of activity surrounding the object. The implications of this flood of data go far beyond astronomy. If 3I Atlas is natural, then the galaxy contains a diversity of materials, chemistries, and dynamic processes far richer than imagined. It would mean our models of planetary system formation are incomplete and that the possible outcomes are far broader than we thought. That alone would be revolutionary, requiring revisions to everything from exoplanet science to our understanding of space organic chemistry. But if even part of Webb's findings suggests artificiality, the consequences are staggering. It would mean that intelligent beings somewhere across the vast void have launched objects, whether probes, derelicts, or fragments, into interstellar space, and at least one has drifted here. Even the most cautious scientific voices now acknowledge the discomfort of the data. They cannot deny it fails to fit neatly into existing categories. Instead, they resort to terms like unprecedented, enigmatic, and beyond current models. The reality is Webb has given us a clearer glimpse of something fundamentally alien, and that clarity has deepened the puzzle rather than simplifying it. The fear is not only about what it means if the object is artificial, but also what it means if it is not. If nature alone can produce such anomalies, then the universe harbors processes we barely comprehend, processes that could challenge our assumptions about stability, habitability, and even life's uniqueness. Astronomers will continue gathering data while 3I Atlas remains visible, but it is already receding into darkness. Its fleeting passage offers us a brief look into a realm of cosmic phenomena previously only hypothesized. The Webb telescope, with its extraordinary sensitivity and reach, has opened a window onto this mystery, and what pours through it is both awe and apprehension. Every spectral line, every orbital deviation, every faint glimmer of strange material hints at a truth more unsettling than we anticipated. Not worse in the sense of catastrophe, but as a vast and disorienting expansion of our ignorance. We are staring at an enigma that resists easy classification. And the more we observe, the deeper the questions become. As analysis continues, heated debates rage in observatories and research centers worldwide. Every scientist examining the data sees the same thing, something profoundly out of place. Yet interpretation divides the community. Some hold onto hope that exotic yet natural explanations will emerge, that new models will tame the strange phenomena. Others reluctantly accept that the artificial hypothesis cannot be dismissed. Either way, the Webb telescope has fulfilled its purpose, showing us the universe as it truly is, unfiltered and unsanitized by our preconceptions. And in the case of 3I Atlas, that reality is stranger, darker, and more disturbing than anyone predicted. The James Webb Space Telescope has a knack for making the familiar seem alien and the unknown even more haunting, and its encounter with 3I Atlas exemplifies this unsettling duality, with every observation revealing complexity that defies all frameworks we've used to understand cosmic visitors. The initial wave of data was startling enough, but ongoing analysis pushes the implications further into realms where astronomy brushes up against the existential. It's not just that 3I Atlas is peculiar, it's that its peculiarity grows with every explanation attempt, leaving us with the feeling that something immense and unfamiliar lurks behind its silent path. One of the most remarkable findings in the extended Webb datasets is the object's temporal behavior. Astronomers generally expect consistent spectral features across sequential observations, except during dramatic outbursts like those seen in comets. Yet, as Webb's instruments observed 3I Atlas night after night, subtle but unmistakable shifts emerged in its spectral signature. Bands strong one day faded the next. Features once stable suddenly sharpened or drifted. Such spectral variability is rare and profoundly puzzling. It indicates the object's surface, or perhaps a subsurface layer, is dynamic, undergoing rapid changes on astronomical timescales. For something journeying through interstellar space, cold and seemingly inert, this restless activity defies the idea of a frozen relic drifting aimlessly between stars. Further examination revealed these spectral shifts loosely correlated with its orientation relative to the Sun and Earth. This suggests, unsettlingly, that some interaction with solar radiation is driving the changes, but in a manner utterly different from known comet outgassing. Instead of releasing vapor jets, 3I Atlas may be reorganizing or reconfiguring its surface chemistry in real time. Such reactivity implies either a composition rich in exotic metastable compounds or, if we entertain a bolder idea, the possibility of intentional surface adaptation. In either case, it evokes unease. The object seems less like a passive traveler and more like an entity engaged in an active process. This variability is not the only baffling phenomenon. Polarimetric observations performed using Webb's instrumentation revealed an unexpected level of polarization in the light bouncing off an object referred to as 3I Atlas. Polarization conveys insights into the surface composition, orientation, and physical structure of materials. In this instance, the findings pointed not to a coarse or chaotically scattered surface, but to one that was intricately organized. The intensity of the polarization hinted at uniformly oriented particles or crystalline structures spanning wide sections of the terrain. This kind of systematic alignment is rare in naturally occurring formations at this magnitude. On Earth, such patterns are usually indicative of manufactured origins. In space, comparable outcomes necessitate highly specific circumstances, such as strong magnetic forces or precisely channeled flows. The detection of polarization to this extent suggests either that the object was exposed to environments far beyond what is common in planetary development, or that some mechanism is shaping the exterior with extraordinary accuracy, one that stands in stark contrast to natural randomness. The mystery only grew deeper when Webb registered subtle emissions in the mid-infrared spectrum. These emissions didn't match what would be expected from sunlight reflection or typical blackbody radiation. Instead, they manifested as coherent, narrow-frequency signals, akin to outputs from thermal devices that are fine-tuned to emit at specific wavelengths. Natural origins for such emissions are extremely limited. Most celestial emitters broadcast wide-spectrum radiation with overlapping frequency bands. By contrast, narrowband radiation typically implies a highly selective mechanism, perhaps a resonant or filtering process. The astronomical community remains reserved in interpreting these findings, but the evidence has compelled comparisons with effects commonly observed in artificial contexts, such as masers. Yet, unlike masers, which form within massive interstellar gas clouds under particular parameters, these emissions originated from a compact object no more than a few hundred meters wide. Known natural phenomena can't account for that. If 3I Atlas is naturally formed, it is like no known natural body. If not, the ramifications are far more significant. A finely tuned narrowband emitter traveling through our solar system points toward purposeful design, technological origin, or possibly relics of something engineered. Even contemplating such a scenario is unsettling, as it compels a reevaluation of our position in the cosmic framework. In a universe already steeped in uncertainty, the potential that we've encountered evidence of intelligent activity is staggering, but the data doesn't allow for easy dismissal. An additional finding, initially deemed insignificant, is now generating serious concern. Webb's sensors recorded recurring dimming in the reflected brightness of 3I Atlas. These dips in light intensity didn't match its rotation cycle, nor did they correlate with any expected shadowing effects from its structure. Rather, they implied the involvement of external modulation, perhaps material intermittently enveloping or emanating from the object before dissipating. The intervals between these dimming episodes were too consistent to be attributed to randomness. They exhibited a rhythm that seemed almost encoded, like a signal carried by visible light instead of radio waves. At first, astronomers met this with skepticism, launching numerous simulations to eliminate the possibility of observational error. Yet, the pattern persisted, resistant to all conventional interpretations. This rhythmic dimming has sparked theories that venture well beyond the standard boundaries of astrophysical comfort. Could it represent an attempt at communication? Or perhaps an unknown energetic mechanism pulsing through the object? Even the more conservative theories raise troubling implications. If the dimming is caused by structured ejection of particles, it implies internal systems that are both active and remarkably consistent. That alone would be unprecedented when compared to comets, asteroids, or debris known to us. The boldest possibility is that these pulses are not natural at all, but intentional signals. The cautious will argue against it. The bold will claim it demands attention. Webb's exceptional sensitivity also detected isotopic signatures that are highly unusual for interstellar objects. Among these were forms of carbon and nitrogen with ratios that don't align with what is typically found in stellar ejecta or forming planetary disks. These discrepancies might suggest that the object originated in a solar system where nuclear processes followed different paths, or possibly in a region enriched by rare stellar explosions. But there is a more disturbing possibility. Large-scale isotopic variation can also result from industrial or artificial processing. On Earth, human-made processes leave behind isotope distributions that significantly deviate from natural occurrences. Observing similar discrepancies in 3I Atlas muddies the distinction between naturally diverse origins and deliberate transformation. At a minimum, this suggests that the object passed through extraordinary environments. At a maximum, it suggests that the object was altered or even constructed. Taken together, the variable spectrum, the polarization data, the narrowband outputs, the regular dimming, the isotopic anomalies, form a narrative that is more perplexing than illuminating. Instead of closing in on an explanation, each new piece of data opens up additional, unsettling possibilities. If this object is of natural origin, then our galaxy contains phenomena so strange that our existing models are sorely inadequate. If it is artificial, then we are not alone, not even under the most conservative definitions of that idea. Neither scenario brings comfort. Both demand deep reconsideration. Through its detailed observations, the Webb telescope has done more than confirm the strangeness of this object. It has brought humanity to a pivotal interpretive moment. Our civilization has long looked to the skies, wondering if we are unique, if we drift in solitude or are part of a larger narrative. Through its silence and mystery, 3I Atlas suggests that the universe is neither vacant nor fully knowable. It hints at a cosmos filled with elements that defy our models, structures and truths stranger than we've imagined, passing silently through our solar system. Beyond the raw data, there has been a significant shift in the intellectual landscape of astronomy. For centuries, the field has thrived on its ability to sort and define planets, comets, stars, and so on into clean categories. 3I Atlas defies categorization. It rejects every effort to simplify or label it. That refusal undermines the foundations of certainty, reminding us that the cosmos is not bound by the limits of our taxonomy. Webb has not merely delivered more accurate observations. It has exposed the myth that more data always brings clarity. In this instance, more data has only multiplied the unknowns. The sense of unease doesn't stem from fear of invasion or destruction, but from a sobering awareness of our own ignorance. If 3I Atlas is only the third such visitor we've detected, how many others have gone unnoticed? And if even one of these exhibits phenomena this extreme, then the universe might be saturated with strangeness, only now becoming visible to us. More troubling still, if this object is artificial, we've inadvertently discovered the remnants or evidence of intelligences whose nature and intentions are beyond our grasp. Are they explorers? Survivors? The last echoes of a vanished civilization? Or are they something entirely different, involved in activities that surpass human comprehension? These unanswered questions permeate every Webb dataset related to the object, lingering between numbers and plots. Meanwhile, the object continues its journey, unmoved by the whirlwind of theories it has triggered. Soon, it will move beyond Webb's reach, slipping into the distant dark of interstellar space. But the echoes of its passage will remain. The faint striations in its cloud, the organized polarization, the timed dimmings, these will linger as reminders, not just of the universe's dangers, but of its deep, disorienting complexity. We are not facing a revelation but a deeper abyss, one that implies the cosmos holds enigmas that resist explanation. As scientists debate, one thing is increasingly evident: 3i Atlas has altered how we view interstellar visitors. The next object from beyond our solar system will not be dismissed as a mere anomaly. It will be approached with expectation, with the awareness that it could bear insights as consequential as any before it. The Webb telescope study of 3i Atlas has changed the rules. Every future visitor will be seen not just as an inert body, but as a potential messenger of knowledge that may reshape our understanding of the universe. In that respect, 3i Atlas has already made its mark, not through its physical passage, but through the disturbing truths it has compelled us to face. When Webb resumed its intense monitoring of 3i Atlas, the mission evolved beyond anomaly logging. The observatory became a conduit between empirical data and speculative theory. The incoming findings were so unlike anything previously encountered that entire research teams were forced to abandon long-held ideas. Each new stream of data was uploaded to global databases, and these findings didn't just refine theories. They challenged the core of how we define cosmic bodies. One of the most revealing elements didn't come from the object's mass or surface. It came from its environmental interactions. The solar wind, a continuous flow of charged particles streaming from the sun, normally has predictable impacts on comets and asteroids. Dust trails curve away. Plasma tails shimmer under ultraviolet light. Charged particles subtly influence orbital paths. But in the case of 3i Atlas, Webb identified unexpected disturbances in the solar wind. Rather than a diffuse cloud surrounding it, the object produced crisp, layered boundaries, resembling ripples emanating from its motion. These resembled scaled-down versions of bow shocks found near magnetized planets.